Hello everyone, I'm Whitney Akinola, and today I have a tutorial on how to filter complex objects using filtered object. If you would like to follow along with me during this tutorial, pause this tutorial and click on the link that I have placed in the description of this video as well as in the comments section. This link will allow you to spin up an instance in your browser of my starter code, and you can follow along. You should see a screen that looks similar to this, and the input and the output should pretty much mimic each other at this point. To get started, we're going to look at how to filter objects by value. Our first use case is to filter out our complex object by value based on the ticker symbol. Okay, so before we start, we have a complex object. The object has keys that are string numerals, so indexes 0, 1, 2, 3, and so on, and each key maps to an object, and that object has a CIK_string, a ticker, and a title. So for our first use case, we want to get tickers that have the substring go in it. So how do we do that? We go ahead and we use the function filter object. So we'll start with payload. We'll pass in our payload and we'll press enter and type filter object. Okay, if you type filter, that's for arrays, but for object, this is filter object. Now I like to stack my function call using infix notation. Now if you press enter, you're going to get autocomplete. You can use that if you like. If not, you don't have to. But let's go ahead and use autocomplete for this. We have our lambda expression, so the autocomplete will do the lambda expression. Let's put our lambda expression under the filter object. Everything will stack and look very nicely. Now, I want to point out that filter object takes in 2 arguments. For this video, I'm going to stick to the word arguments. There are, in functional programming, there are parameters and there are arguments. But I'm going to call everything arguments for the purposes of this tutorial. Most of the time I swap them. They're very similar, but they have different meanings. But for this tutorial, we're going to stick to arguments. Okay, so you can see, so value, key, index, these are arguments that I'm defining ahead of time that I will use in my lambda expression. We want to use value, so we don't necessarily need to use everything that we predefine. So we're going to use value. So we'll type value here. Okay. Now we need to do something with our value because our filter object takes in a condition, right? Literally, we're passing in payload as our first argument, and then this lambda expression that's going to do something with the payload. Lambda expressions are anonymous functions, okay? So now we need to do something with it. We're looking for the ticker symbol that has go in it. So our ticker symbol is represented as a ticker in our value object, right? So we do dot ticker, and now we have to tell it what to do, some kind of condition. So we need to look for a function that will help us with our condition. So I'm going to use, you can use a function or you can use an operator, some kind of comparison. What I'll do is let's try contains, and we'll pass in our string go, our substring, and let's see what we get. You can see this has returned a complex object, right? So we have our object, which has a key of 2, and then it has a value of another object. Now, what happens when we want to work with key? So for this use case, we're going to turn a filtered object that has the even keys of the unfiltered object. So 0, 2, 4, 6, 8, and 10 should be in our new filtered complex object. So to do this, we'll start with removing our right side of the argument. All right, and that's removed. And now we want to do something with our key. So we'll type key, and we want to get the even keys, right? So how do we do that? Well, it's typical in programming and in math to use modulo. There is a function called mod. Let's use that. And we're going to mod it by 2. And when we mod it by 2, we need to compare it to something. So we know if we want to get evens, it's pretty standard to mod by 2 and compare it to 0. So we'll use the equals operator and we'll compare it to 0. You call the function mod with the key, which is a string, and false. Those are our two parameters or our two arguments, right? We need to isolate these two things, right? We need to isolate the key mod 2 from the comparison because mod takes in two number types. So we need to isolate that expression from the comparison. To do that, we can put parentheses over the first expression to force DataWeave to evaluate that first. We have some working code. We have 0, our output looks good. We have index 0, 2, 4, 6, 8, 10. How does this work? Because mod took a number type, but we passed in a string. Well, DataWeave implicitly casted the key to a number type. The key was a string and it casted it to a number type. Now, I may not want to implicitly cast things. I may want to explicitly cast so that I could signal to the person that's maintaining the code or someone that's coming behind me that key is in fact a string and we had to cast it to a number. So we can cast explicitly using the as operator, and we can call it number. And there you go, key as number mod 2. Now, if you're like me, I love parentheses. I love making things literal to developers, even though you don't have to do it. You can put an extra parentheses there. So this is how you would filter using keys. Now, how would we filter using the index? If we wanted to do the exact same thing, how would we do it? Well, we would just swap out the key for the index, okay? Same thing, but do we need the as number? Remember, index is a number already. Do we need as number? No. So we can clean up this code and remove that. We'll also remove the extra parentheses. And there you go. You have the same exact thing. So I've shown you so far how to filter by value, key, and index. You can also use all three of these arguments and build a complex Lambda expression if you needed to. Now let's talk about the $ syntax. So DataWeave allows you to write Lambda expressions using a shorthand syntax called $ syntax. So the dollar represents the value, $$ represents the key, and $$ represents the index. Keep this in your memory because sometimes this comes up as a possible interview question. Okay, so now that we know that, I want to do something interesting with values. Let's start. So let's do something interesting with values. So we remove our Lambda expression, period. Why? Because now we don't need to write this long form of our Lambda expression. Let's write a simple expression that returns a filtered object if the value is an object. So value is $, and we can check to see the type of something by using the is. I believe this is an operator, and we can type is object. Now notice this. Our condition says filter the value based on if it's an object. Well, our value is an object, and for each key, the value is an object. DataWeave has returned new unfiltered object, right? So what happens if we change it to array? Well, let's say we wanted to manipulate this value and drill in a little bit deeper. Maybe we could go back where we looked at that ticker value that had the GO in it, the GO substring, and just rewrite that. So we want our value, we use $, dot, ticker, and we had to put parentheses around it, right? So sometimes you may get an error. Let's go back and look at this error. And so it just simply, it didn't know what to do. It couldn't coerce the first string. So sometimes when you get errors around DataWeave, like coercion errors, or DataWeave just doesn't know what to do, you can put these parentheses around your expression, and that can clear up a lot. So these parentheses have a special name. They're called evaluation parentheses, okay? Our first example using $ syntax. Okay, all right, that's good, Whitney, that's great. But what about the modulo use cases? How would we rewrite this if we wanted to return all the even keys? So for this, we would use the double $, and then we want to get evens. Remember how we did that? We used the mod function, okay? And then we modded it by the number 2 because evens and odds or ons and off are it's just two combinations, right? It's either on or off, right? Even or odd. So we use 2, and then we had to compare it to 0 because if it's even, there's no remainder. If it's odd, there's a remainder of 1, right? So we use that. And then, okay, we're getting this transform again. So we're going to put some parentheses around it, our lambda expression. And then now we're also getting that error again, right? Where we had, you passed in this key and you passed in this Boolean. So now we need to add some additional evaluation parentheses to tell DataWeave to take care of the mod first, right? And our condition, so take care of the mod. All right, so now we have this, right? Now notice that if I came behind you and I've never seen the payload, right? Maybe I have the payload, maybe I built an API. Maybe I built an API and the payload is, somewhere, or I don't have access to the payload. As a developer, I have no clue what this is. So you definitely want to, 1, comment your code. 2, I don't know the type of $. Now, we know that DataWeave did this implicitly. So, but we want to tell the developer, hey, this is of type string, but we're casting it to type number. So we're going to add as number, and you would write a very nice comment. If you're like me, you would take it further. You would add another parentheses here for the cast, and this is your final output. How would you do this for indexes? Well, if you remember from the previous example, how we wrote this longhand is very similar. All we do is we switch from using the key to now using the index. So we add an additional $, okay, here, and index is already a number, so we don't need to coerce it or cast it to a number. So we can remove this. And there, we've done it. So that's it. That's all I can show you. Well, this concludes this tutorial. You could take this a step further and you could play with nulls. You can make this example more complex. All right, see you in the next video. Be sure to subscribe, hit the notifications, leave a comment, like, you know, all of that jazz. Bye-bye.